Hey guys, what's good? So today's video is going to be a bit different in that normally I have a finished project and I take you through it step by step. I talk about it, it's all scripted and formalized. However, today I'm going to do something a bit more freeform and I'm going to take you with me as I build something. Anyways, as for what I'm building today, a while back made this little bouncy ball out of NinjaFlex. However, I was kind of disappointed in how it bounced and where it bounced, in that it was kind of irregular. Like, you'd throw it, it might go really high, it might go really low, it might bounce across the room. And I realized that this was because of the infill. I had just printed a full sphere and my slicer for my 3D printer filled the inside of it with a grid pattern. And when that grid pattern is repeated upwards vertically, it leads to inconsistencies in how it can be compressed. With flexible materials like NinjaFlex, this will play a much larger role. This is because when you squish it from the sides, it'll squish much easier than when you're squishing it vertically. This is a result of that pattern, that grid pattern, being repeated upwards. A while back, while I was thinking about that problem, Angus from Maker's Muse made a few videos on using 3D infill for 3D prints. And he made a tutorial on how to make the pattern for any 3D printable design. And it basically fills the interior of the design with a grid-like lattice, except it's three-dimensional, so it's more cubic, I guess. And when I saw that, I realized that it could be a great solution for the problem I'm having, as it's isometric and consistent throughout the whole volume, and could allow me to have consistent elasticity and compression in a bouncy ball. So today, we're going to figure out if using 3D infill can help make a better bouncy ball. Alright, so here I am in Mesh Mixer, and the first thing we're gonna do is go to Edit, and we're going to make it hollow. So then, since I want it to have a 3mm outer wall, I'm gonna set it 3mm right here. I'm gonna do update. Then I'm gonna separate the two parts of it by separating shells. And then I'm gonna hide the larger one. And then with the smaller one selected, I'm gonna go to select. I'm gonna do Command A in order to select the whole thing. Go to edit, go to flip normals, and click that. Then I'm gonna go to edit, I'm gonna make pattern, I'm gonna go to lattice, because we want a lattice structure. And now I have the options to put in the parameters that I want. So I want them to be 3mm in diameter. So I'm gonna set 3mm right here. And you can see they all got a bit thicker. And then I want them to be spaced out by 7.5. This is like the density of it. And then I need to make sure it's set to subtract, and then I can click update. Alright, so now it made the pattern, and now what we can do is press accept, and then this other one, which is what we had before we applied the pattern, we can just delete that. Then now we have this, we can go to select, we can do Command A to select all of it, then go to edit, flip the normals, and then unhide the other one, select them both by using shift click, and go to combine. And now if you see, if we apply the transparent filter, you can see that we have this internal structure on the inside of this. So I had run out of filament mid-print, but that's alright because it actually looks really cool and it shows the pattern really well. However, this prototype is not without its problems. The first of which I noticed was that it's very hard. It's not easy to compress. And so to solve that issue, I think I'm going to decrease the density of the cells to 15 millimeters. On the last one, I had them at 10 millimeters. So this one's gonna be 150%. I'm worried that with that, the individual tubes making up the cells are gonna be much longer, and because they're quite thin, they could either fall down or wouldn't transfer force well. So I'm gonna increase the diameter of those tubes to 4 millimeters. The last thing, which is a pretty minor issue, but not to be overlooked, is that some of the layers early on in the sphere kind of fell down a bit. I printed this at 0.35 millimeter layer height. I'm gonna lower that to 0.25 millimeter layer height, and hopefully that should prevent those little layers from falling down. I also have a hypothesis that making a thicker outer wall might also have a capacitive effect on spreading force around the ball. However, I'm worried it could compromise elasticity too. I'm gonna try it with 4 millimeters instead of 2 millimeters. Well guys, on this latest prototype, I am very satisfied with the results. It bounces very nicely, feels good in the hand. It's a bit tough, but it's not that bad. And as you saw, it bounces quite well. I did some quick testing, and I actually think I'll be fine if on the next prototype I use less density with the 3 millimeter tubes. So I'm going to decrease the density to 17 millimeters. I'm also going to decrease the wall thickness to 3 millimeters and decrease the diameter to 3 millimeters. I think that with all these variables, there's a bit of a sweet spot at which they yield the best result. And I think that this might be going out of range of that, but we'll see. Well guys, the third ball does not bounce as well as the last iteration. It feels varyingly compressible, not as uniform as the last one. However, it still bounces significantly better than the original. Anyways, I might as well do some testing to quantify my results. Due to the inconsistencies, the original at most bounced 2 feet 8 inches from a drop of 68 inches, and at the least 1 foot 4 inches. The second ball bounced 3 feet 9 inches on average, and the third ball bounced 3 feet 4 inches on average. Where you really start to see the difference is when you do more than just drop the ball and really put some force into it. These clips show it best. As I thought about it, I realized that there's a fundamental limit to this whole thing. NinjaFlex will stretch more before breaking when stretching in parallel to the layers, and less when perpendicular to the layers. The opposite is true for compression. When a ball hits the floor, the sides stretch out and the top and bottom compress, rubber banding back into shape and launching the ball up. As a result, the ball bounces best when the layers are parallel to the surface they're bouncing off of, hence an uneven bounce if the layers are perpendicular to the surface. This is a result of the manufacturing process of 3D printing, but paradoxically, 3D printing is the only manufacturing process that can actually create this as a seamless geometry, making it not super practical for making even elasticity. But that makes this knowledge all the more useful for making uneven elasticity. The work I was doing here reminded me of a project by the Disney Research Group that allowed varying density microstructures to allow different flexibility in the different parts of a 3D print. The techniques I used here were quite similar and could probably be used in much the same way. Anyways, thanks for watching this video. As I said, this one is kind of different because most of my projects are like, boom, finished project, here's how to make it, blah blah blah. But in this one, I showed mistakes, I showed improvement, and I showed the overarching maker process, which is where I think a lot of really interesting information lies. Let me know if you want to see more videos like this. Anyways, if you like this video, you should know what to do, and if you want to follow my work, then subscribe. I'll catch you later. XYZ Aiden out.